Hello everyone. Today I'll be presenting my project titled Academic Research Paper Recommendation System. The goal of this project is to build a database-driven system that helps students and researchers discover relevant academic papers quickly and efficiently. Throughout this presentation, I'll be explaining the motivation behind the project, the database design, and the SQL queries used for getting these recommendations, and finally, outputs and conclusions. Coming to the abstract, the purpose of my system is to simplify the process of finding research papers related to the user's topic of interest. Instead of using machine learning or external APIs, this system relies purely on structural SQL queries and relational database design. I have created tables for users, papers, authors, keywords, citations, and a lot of many-to-many relationship tables. Using these tables, the system can recommend relevant papers based on the shared common keywords and authors, citation relationships, and popularity. And the project demonstrates ER modeling, normalization, referential integrity, that is such example foreign key, and SQL-based recommendation strategies. Now, coming to the problem statement and objectives, the main problem I wanted to solve in this project is the challenge students face when searching for academic papers throughout their studies. With thousands of research articles available online, finding relevant ones takes a lot of time, right? Many students struggle to identify which papers are meaningful, credible, or related to their academic area of study. To address this, I have created a structured database that organizes research papers and metadata, identifies relationships between papers, generates recommendations using SQL logic, and helps users quickly discover relevant academic content. The overall objective is to provide a simple, efficient, and database driven recommendation system for the students. Now, coming to the ER diagram, this is the uh, ER diagram of the entities. The main entities includes users, papers, authors, keywords, citations, papers, keywords, and user interactions. Now coming to the ER diagram, um, because papers can have multiple authors and multiple keywords, these relationships allows us to connect papers with authors and topics, which is essential for generating recommendations. The citation tables the citation tables shows which papers have reference to each other, enabling citation-based recommendations. So here, users and authors have many-to-many relationships, and papers-to-paper authors have one-to-many relationship, and authors-to-paper authors have one-to-many relationships, and papers and paper keywords user interactions have one-to-many relationships, and keywords and citations have also have one-to-many relationships. This is the entire ER diagram of my project. And coming to the tables overview, in my database, the tables I serve have serves different purposes. User tables. Firstly, user tables stores basic user details such as affiliation, username, user ID, and created date. And coming to the papers table, it has title, abstract, year, DOI, citation count. Uh, Usually, what research papers have in the online websites. And authors table have author names, author IDs, and affiliations, and ORCID. And there are some keywords, keyword list, such as keyword ID and keyword name. And also we have citations that has relationships between papers. Citations table cracks which paper cite each other. And coming to the junction tables, we have two junction tables, papers authors and papers keywords, that has many to many relationship between papers and authors. And for papers keywords, many to many relationship between papers and keywords. All the tables are normalized to 3NF to remove redundancy and maintain data integrity. And coming to the purpose, yeah, these are all normalized to 3NF, which supports multiple recommendation logics and ensures referential integrity. Coming to the SQL queries, these are the summarized SQL queries. Coming to my document, I have created all the information about my project, and also I have listed all the queries that I have used for my um, database creation. Here I have created my research paper recommendation system database, and then I have created each table such as users, papers, authors, and paper authors, keywords, paper keywords, and citations. Every table and user interactions, which has user ID, paper ID, interaction type, and everything related to my database. These are all the tables these are all the tables that are created in my database. And then I have inserted all the required values into each database, like each table in the database. These are all the queries that I have run, like insert into table name and the column names, values, and each values of the users. Have created everything. I have inserted all the each and every value to the um, tables. And now coming to the actual queries, SQL queries for my project, for to recommend the actual papers to the users. Um, I have run seven queries. I have run seven queries. Coming to the query one. I have recommend papers. I have written the paper uh, to recommend papers by shared keywords. This is the most common recommendation logic. In this query, I am identifying research papers that share the same keywords as the selected paper. The query starts by taking all the keywords linked to the input paper and then searches for other papers in the database like that are associated with those same keywords. And I also used joins to get the relevant recommendation by using two or more tables. And then I have used mm, Mm. Now coming to the queries, this is the query that is used to get the keyword-based recommendations that shows papers that are closely related into the topic. Here I have got the result with two distinct tables that are papers and the keywords, depends on the keywords. These are all the results that I got from the table, from the database. These are all the recommendations that I got from the database. And the second query is recommended papers by common youth authors. And here I can find research papers that are written by the same authors as the selected paper. The query first identifies all the authors linked to the input paper and then checks for the other papers in the database that share those same authors. I have used a self join on papers authors tables that is used to match papers that have at least one author in common. and the original paper is excluded from the results to ensure only the related papers are common. The final output displays the list of the papers that are similar because they are written or co-written by the same authors. This is the query that I have run, and these are the results I got. All the things related to the AI, that is deep learning and deep reinforcement learnings, and related to the AI techniques. And the third query is I recommend highly cited papers. It the data will be retrieved based on the popularity of ranking. In this query, I have retrieved the most influential research papers by ranking them according to their citation counts. The query selects the paper ID, title, and the total citation count from the papers table, and then orders the result in descending order, so that the papers will with the highest number of citations appears first. I have used limit of 10 so that I can just retrieve the top 10 of the papers, influential papers here. You can see the query, and I've got the top 10 influential papers here. And coming to the fourth query, I've I have wrote the query that is used to get the recommended papers based on the user interactions, like the users based on the user interactions. This is done by the user interaction tables that contains user ID, paper ID, and interaction type. In this query, I am recommending papers by analyzing how users interact with different research papers, such as viewing them, liking them. The logic begins by identifying all the users who interacted with the specific input paper. And I have used join with user interaction and papers tables. These are the recommended papers that are retrieved by using the user interactions, like most the use on which the user will like the most. And coming to the query 5, this is the query that is written to recommend papers using keyword frequency. Like here we count how many how many keywords a paper shares with the input paper, and this is the query I have written. If there are more like these are the titles, like papers that have more shared keywords. If the shared keywords are higher, the relevance of these papers is also higher. That's what I took from the took to get retrieve the papers, and that's what I have written by the query. I've used join and where and group by order by clauses. And here for the query 6, I have recommended papers using citation relationships, papers that cite the input paper. In this query, I'm finding the research papers that cite the selected input paper. And this result displays papers that are academically connected through citation, showing which works consider the selected paper important or relevant to their research. And this is the one I've got, optimization algorithms in ML based on the cited paper ID 8. And coming to the papers that are cited by the input paper, this type of citation recommendation is useful for exploring the background literature or forming a complete understanding of the research topic. I'm retrieving the papers that the input paper itself references by checking where the input paper appears as the citing paper in the citation table. This is the one I've got. And coming to the last query, this is hybrid recommendation, combines shared keywords and citation counts. In this query, I'm combining keyword matching the citation counts to generate a more accurate and balanced recommendation. The query first identifies papers that shared keywords with the input paper by using a self join on the papers keywords tables. And the final result provides the hybrid recommendation list that balances relevance keywords and important citations, giving users a high quality research suggestions. Here I have used two. Here I have used paper keywords. Yeah. This is the seventh query. This is all the recommendations I have got through hybrid recommendation system, based on both the keywords and citations. Now coming to my slide, these are all the query results and the queries that I have run for each logic. These are all the query results. Now coming to the conclusion. In conclusion, the academic research paper recommendation system demonstrates how a relational database can be used to create a smart recommendation engine without a need of machine learning. The project covers ER modeling, relational schema design, normalization, SQL joins, grouping, ordering, and recommendation logic. This system successfully organizes the research papers, identifies meaningful relationships, produces relevant recommendations, and helps users discover academic content more efficiently. In the future, integration with digital libraries and more advanced analytics, we can like this project can be expanded using machine learning, full text research, integration with digital libraries, and more advanced analytics. Thank you for listening. I'm happy to answer any questions in the comment box. Thank you.